All right, so I'm going to go over all the questions that is sent you on that latest worksheet, and that's how your quiz will look like. So you will have exactly one problem that will look like this, number one, and then you will get one problem like number two where it's fill in a blank, and then you will get four other ones that you just have to be able to create the proof from scratch. All right, so now when you're solving for this one, the first one that you're going to do is you will create your two-column or your T-chart, and we will put our statements, and we will put our reasons. Right, then we will put whenever we're writing this, first we're going to put whatever's given to us. So it is 4t minus 3 is equal to negative 20. And then our reasoning is given. Right, now this one I picked to go over for a reason because you can solve this one of two ways. And I can distribute this 4 in, and my next step would then be 4t minus 12 is equal to negative 20. Now, there is a property that's called multiplication, but when you're doing multiplication, that is you're multiplying both sides by the same number. So that becomes AC is equal to BC. In this case, we're not multiplying both sides by the 4. We're just distributing this 4 in. So this is our distribution property. All right, so you see the difference between multiplying where we would have had to multiply both sides by that 4. In this case, we're only multiplying the one side, and we are distributing it in. So that's our distribution property. All right, then from here, if I want to solve this, I would add over this 12 to both sides. So I would get 4t is equal to negative 8. And from here, our property is our addition property because we added this negative 12 over to both sides to get rid of this minus 12. All right, remember, you do not have to show me your work when you're doing this. You saying addition property is showing me that you are actually adding 12 to both sides. Right, that is telling me that this is what you are doing. So you don't need to show your work. Now, from here, if we want to solve for t, we would divide each side by 4, so t is equal to negative 2. And then our property is we're dividing each side by 4, so it is our division property. All right, this is it for this number, the first one you have. You will have one question that's similar to this on your quiz. Let's move on to the next one. All right, now this is the next problem that you're going to be asked to do something like this, where I will give you part of your proof filled in, and you just have to fill in these blanks. All right, now this is one of the questions from your packet, but if you notice, I did do this a little bit differently than how your packet did it. But let's go ahead and get started on this. Now, before you do anything with this actual proof, you should go over here and fill in everything that you can on your drawing to see how can I prove that these triangles are congruent. And remember, I'm going to use two different colors. It says VB bisects angle EVO. So when I look, here's my angle EVO. And when BV bisects it, that means it is cutting it in half. So I know I can put this arc mark here and this arc mark here because it's creating those two congruent angles. And then it tells me it bisects EBO. So it's bisecting EBO as well. And when it bisects EBO, same thing. It's going to create these two congruent angles. And remember, I'm putting it in blue because although it tells me it's bisecting, I needed to know what bisecting meant in order to do this. Right? Then there's something else I can add. I know that this side, BV, is part of both of my triangles. So I can say it's congruent to itself. Now I look, can I say the triangles are congruent? Yes, angle, side, angle. So by doing this, I'm formulating and creating a plan. And now I need to talk about every arc mark, every tick mark, every angle, side, and angle. I need to make sure I'm discussing it in my proof itself. All right, so when you're doing this, remember, the very first thing that you ever write down is your given information. So it says given, I am going to write this all in. VB bisects angle EVO and angle EBO. All right, you will definitely have enough space to write this on your paper. So now I talked about my given information, so I know I'm done with this. Then remember, when we said it bisected, that is where we could say that these angles were congruent. So if you notice, the next statement that is provided for you is that angle 1 is congruent to angle 2. And that's what we said here with these arc marks. And that angle 3 is congruent to angle 4. And that's what we said, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. That's what we said with these arc marks. So why were we allowed to put those arc marks there when we were filling in our triangle? It's because we knew what the word bisect meant. When we saw it bisects our angles, we knew that meant it created two congruent angles. So when you know what a word means and you're able to use it and apply it, that means you're applying its definition. So it's definition of angle bisector. Remember, you can use abbreviations, so you can use the angle symbol, and you can put BIS if you want to for bisector. All right, now since I talked about these angles, I'm going to cross them out. Right? A lot of times I like to label what I'm discussing here since I'm saying angles are congruent, and I'll also cross out these A's here. So that means the only thing I have left to talk about now is this side. So in this third part, that's what I have to say. And this side is this side BV. So it will be segment BV is congruent to segment BV. And remember, whenever you say something is congruent to itself, you need to know the last video you watched, 20C, where I gave you those definitions. You need to know all of them. And one of the definitions I went over with you is reflexive property. And that's where you say the same thing is congruent to itself. When it's a shared side, when it's a shared angle, when it's a shared side, it's only those two. All right. But we would then say reflexive property. So now that's my side. I talked about this tick mark, and now I talked about this side. So now I'm finished discussing the everything that I have here. So now I can say the triangles are congruent. So I'm just going to go ahead and say that triangle BEV is congruent to triangle BOV. And we knew it was by angle side angle, which is what we said here. So now we finished talking about that. Now, if I want to show that angle E is congruent to angle O, I can look here and see, well, E and O are in the same position. And as we've learned before, when they're in the same position, that means that they have to be congruent. So we can say that angle E is congruent to angle O. And this is something that you were able to do since section A. But now we're giving it the correct name, the way that you need to name this. It's not just, oh, well, they're in the same position. We need to be more formal with the way that we talk about this. So it is corresponding parts. So that means corresponding that they're in the same position. Parts means angles or sides. So when the angles or side are in the same position of congruent triangles, well, we know that these triangles are congruent because we have this congruency statement. And we knew that when we wrote that they're congruent, we're allowed to talk about them in further detail. So of congruent triangles are congruent. Now, this is nothing new. This is something that we have been doing. 20A, this is everything that we did. But now we're giving it a more formal name. And another way that you can write this is CPCTC. That's how you'll see me write it going forward. All right, but corresponding parts, meaning sides or angles that are in the same position of congruent triangles, when we say that they're congruent with this congruency statement, are congruent. And we knew that. If I then said here, EV is congruent to which side? If I asked you what segment is EV congruent to, I have no doubts that you would all know it's congruent to OV because they're in the same position. That's how you would describe it to me. But now we will use a more formal name that because they're corresponding and corresponding parts of congruent triangles are congruent. All right, let's move on to the next one. All right, so this one we're given that angle W and angle Y are right angles. Then we're given that VX is congruent to ZX, X is a midpoint of WY, and we want to prove that these two triangles are congruent. Right? So remember, we're going to start filling in everything that we know. Well, when they tell us that they're right angles, we need to know what that means. And the right angles tells us that they are boxes here, and that tells us that these are right angles. Right? So we knew what right angles meant, that it's 90 degrees, and we knew that that symbol meant that it's a box, which is why I'm putting it in blue. Right? Then it says VX is congruent to ZX. Well, here's VX and here is ZX. We know that they're congruent. I'm putting that in black because it's explicitly telling me that they're congruent. Then X is the midpoint of WY. Well, what does it mean to be the midpoint? It means it's directly in the middle and it creates two congruent segments. So since I knew what the midpoint meant, I can then go ahead and fill that in. Now I look and see, can I say that they're congruent? Yes. Here I have that my hypotenuse is congruent and I have my legs that's congruent. So I can then say HL. So now I created and formulated my plan. Now I just got to just write it out. So here I will write out my statements and my reasons. I might run out of room for this. So if I do, I'm just going to have to just go scroll down, and then you're just going to have to lose the given information that's there, but we'll have it written already. Remember, the first thing that we do is we write what is given. So since we're starting from scratch, I'm going to write this all. Angle W and angle Y are right angles